So today we're going to look at why we actually need logs and how we use logs and how we rewrite them so that they don't have to be in terms of logs, or how we rewrite exponential equations so that they can be logs so that we can use them. Before we start, I just want to look at two examples. If we look at 3 to the x equals 81, if you were going to solve for x there, you know that you have to rewrite this 81 to be in base 3. So we bring down the first part of the equation. We rewrite 81 to be 3 to the 4th power. Then we know, since we have 3 to the x and 3 to the 4th, that since the bases are the same, we can cancel out the bases and we get x equals 4. If we look at the second example where we have 5 to the x equals 17, it's not as simple because we can't get 5 and we can't get 17 to have the same base. So when we have situations where we can't get the same base, we need to be able to undo that exponential equation in order to solve it. So in order to undo that exponential equation, we need to use a log. To quote-unquote undo the exponential equation, since we can't get those to be the same base. Since they don't have the same base. So we know how to solve exponential equations as long as we can get the bases to be the same. Now we're going to start exploring logs, because we can use logs in order to solve exponential equations where we can't get the bases to be the same. So our logs and our exponential equations are just inverses of each other. They're opposites of each other. They're like multiplication and division. They undo each other. So we use logs when we need to solve exponential equations that we can't get in the same base, and we can use exponential equations to solve logs. So we can kind of go back and forth. So today we're just going to look at going back and forth between logs and exponential equations and how we would write those. So you might be asking yourself, what is a log? And a log is just a fancy math word for how many of one number do we need to multiply in order to get another number. So all we're really saying is how many of one number do we need to multiply to get another number. So the key here is that it's one number that we're multiplying to get the next number. So it might look like something like, how many 2's do we have to multiply to get 8? If I asked you how many 2's we have to multiply to get 8, you would tell me 2 times 2 times 2 equals 8, or that we need to multiply 3 2's in order to get 8. But we know in math we don't love writing things in lots of words, so instead of having to write out like we need 3 2's to multiply 8, we came up with a symbol for it, and our symbol and our notation for it is just log. So let's look a little bit further at how I could write this. So I know that 2 times 2 times 2 is really the same thing as saying 2 to the third equals 8. So when I want to rewrite this as a log, instead of writing out in words what I had there, that we need to multiply 3 2's in order to get 8, I can say log base 2 of 8 equals 3, because all that this log base 2 of 8 is saying, all that this part is saying, is how many 2's do I need to multiply. So how many 2's do I need to multiply to get 8? And we said it was 3. So instead of having to physically write out how many 2's do we need to multiply to get 8, we have a symbol, we have a notation that says log base 2 of 8. So when we read this, we would say log base 2 of 8 equals 3. So it's the same exact thing as saying how many 2's do I need to multiply to get 8. So let's look. Would these be the same thing? 5 times 5 times 5 equals 125, and log base 5 of 125 equals 3. Well, we know that 5 times 5 times 5 is really 5 cubed equals 125. And now we know that log base 5 of 125 is just asking us how many times do we have to multiply 5 to get 125. So they are the same thing. They're saying exactly the same thing. They're just written in two totally different forms. The first one is written in exponential form. The second one is written in log form. So it's just different notations for us saying the same thing. So when we write things in exponential form, the first one was in exponential form. So something like 4 squared equals 16 is exponential form, versus log form would say log base 4. So how many 4's do we need to multiply to get 16? And the answer is 2. So if you notice, all that's happening is my base is staying exactly the same. My base is always 4. Whether I'm in exponential form, this is my base in exponential form. In log form, this is also my base. My base is always going to stay the same. My base isn't changing. My exponent in exponential form becomes my answer in log form. And my answer in exponential form becomes the number I'm applying inside my log function. So when I'm switching from exponential form to log form, essentially all I'm really doing is taking these two pieces and switching their location when I have to rewrite them. So if I wanted to, for example, write 5x equals 25 as a log, I want to make the log, so an easy way for me to remember to make the log is I want to have an L. I'll do that again so you can see. I want 5 first. Oop. Then I'm going to go over to 25 to make an L. Back to the X. It's almost like I'm making an imaginary bubble L in order to get the answer. But so if I want to rewrite 5 to the x equals 25 as a log, I'm just going to write log base 5, because my base always stays the same. And then I switch 25 equals x. If I wanted to go the other way, if I had, for example, write log base 2 of m equals 3 as an exponential equation, or I could say an exponential form, same thing. If I want to do that, all I'm going to do, my shortcut here is, since I want to get to exponential, I'm starting with the 2, I'm going to the 3, and then to the m, makes a big E to remember. So I really have 2 to the third equals m. So let's write log of 625, log base 5 of 625 equals x in exponential form. So I want to start at the 5, I want to go over the x to the 625, or my base stays my base. My answer becomes my exponent, and the 625 becomes my answer. What about if I wanted to write 10 squared equals y as a log? So if I wanted to go from 10, I go over the y, and back to the 2, so I get log base 10 of y equals 2. So all you're going to be doing today is switching back and forth between the forms and getting used to rewriting them.